All right, this is lesson 1.3, Introduction to Combinatorics and Factorials. All right, so before we get into what combinatorics is, we need to review what a factorial is. You might have seen it before, you might not have. It says factorials are products of all positive integers less than or equal to the starting value. They are written with an exclamation point at the end. All right, so right here we have the general form of a factorial. It says if we have a number n factorial, that's going to equal n times n minus 1 times n minus 2 times n minus 3, all the way down to 1. Now, if this is confusing for you, I have an example of what this looks like over here with 4. So 4 factorial is equal to 4 times 3 times 2 times 1. I'm going to start at 4 and I'm going to go all the way down to 1, multiply them all together, and I would get 24. So in this box, it's left blank. It says 7 factorial is equal to what? I want you to pause the video and I want you to see if you can write out what you think 7 factorial will be. I will give you the answer in 3, 2, 1. All right, so if you wrote out 7 times 6 times 5 times 4 times 3 times 2 times 1 and put that in a calculator and got 5,040, then you are correct. That is what 7 factorial is. Okay, a couple interesting notes about factorials. Right here, first it says you cannot take factorials of negative numbers. In fact, you can't take them of decimals either. So this is nice because we're only working with positive whole numbers. All right, and then over here, we say 0 factorial is equal to 1. Now this might be a really weird concept to you. If you'd like a deeper explanation about this, make sure you ask me about it in class, but for now, just trust me. Okay, moving on to combinatorics. So first of all, what is combinatorics? I have a box right here where we're going to write the definition of combinatorics. All right, so the definition says a branch of mathematics involving selecting, counting, and arranging numbers. All right, now if that definition doesn't make any sense to you, that's okay. We are going to dive into what that means later on. First, there are a couple formulas that I need to make sure you know how to do before we get into what they mean. All right, so there are two formulas that we're going to be working with. One is the combination formula, and the other over here in the bottom right is the permutation formula. All right, so the way we write these, there's two ways to write them. We could either write in C R, or we could write C and then in parentheses in comma R. Same thing over here. It's the exact same as a combination, but now with P instead of C. And the formulas are also very similar. So the actual formula, which I'm going to go ahead and put a box around those. The formula for combinations is n factorial divided by r factorial times n minus r factorial. The permutation formula is the exact same, it's just missing this extra r factorial in the denominator. All right, very good. Now, if you have your highlighter, I really recommend you highlight this stuff that I've done down here. So it says use this formula, so combinations, use this when the order of outcomes in an event does not matter. Right? And then for permutations, it says use this formula when the order of outcomes does matter. And again, we'll talk about what that means in just a minute. Let's see if we can use these formulas first. All right, so in these problems below, we're going to use the formula with actual numbers now. So right here in the top left, I'm going to do the combination C of 5, 3. Right, so the way I use the formula, the first thing I need you to recognize is that the first number is always n. So I can go ahead and label n is going to be 5. The second number is always r. So I can label r as 3. And then I can use my formula. So the formula in the box up here says n factorial divided by r factorial times n minus r factorial. So plugging in what I know, this is 5 factorial divided by 3 factorial times 5 minus 3 factorial. And of course, we just learned what a factorial is, so I could write this, expand this out a little bit. 5 factorial is 5 times 4 times 3 times 2 times 1. On the bottom, I'm going to get 3 factorial is 3 times 2 times 1. And then 5 minus 3 factorial, that's really just 2 factorial. So this is going to be 2 times 1. All right. Okay, very good. If we go through this problem, you should notice that on the top and the bottom, some things are going to cancel. So 3's cancel, these 2's are going to cancel, these 1's are going to cancel. And I'm left with 5 times 4 on the top divided by 2 times 1 on the bottom. 5 times 4 is 20, 2 times 1 is 2, 20 over 2 is 10. So the combination of 5 and 3 is 10. All right, now let's do the same numbers, so 5 and 3 again, except let's jump over here and let's do the permutation. All right, so really similar formula. Remember, we're just missing that extra r factorial, but I'm going to start it off the same way. I'm going to say n is going to be 5, r is still going to be 3, and now my formula is n factorial divided by n minus r factorial. So this is 5 factorial divided by 5 minus 3 factorial. And of course, 5 minus 3 is 2. So we end up with, if I'm going to write this out, 5 times 4 times 3 times 2 times 1 on the top divided by 2 times 1 on the bottom. 2's are going to cancel, 1's are going to cancel, and I'm left with 5 times 4 times 3. Or that is 60. All right, so one thing I want you to notice here is even though we used the exact same numbers, 5 and 3, the combination was way less than the permutation. 10 is less than 60. In fact, that will always be true. If you're doing a combination and a permutation and you're using the same numbers, the combination will always be less than the permutation. And that's because of this extra r factorial in the denominator. If you divide something by an extra number, okay, in other words, you're dividing it by something bigger, then you're going to be left with a smaller piece. All right, very good. What I want you guys to do is jump down here on these two problems below. So the combination of 5 and 2, and then the permutation of 5 and 2. I want you to go ahead and pause the video and see if you can use the formulas to solve those two problems. I will give you the solution in 5, 4, 3, 2, 1. All right, so if you had the combination of 5 and 2, you did the formula and you got 10, good job. If you did the permutation of 5 and 2, used the formula and you got 20, great job. Okay, now a couple things I want to point out to you before we move on. So first of all, you'll notice that the combination of 5 and 3 and the combination of 5 and 2, they're the exact same answer, all right? And that's because I want you to pay attention to, first of all, this right here. So we have 5 factorial on the top divided by 3 factorial times 5 minus 3 factorial. Now, 5 minus 3, that is just 2. So this is really the same as this, right? And if I'm going to get out my highlighter real quick, if I look at this, and then I look at this, oh look, those are the exact same formula. Yes, I know the 2 and the 3 have switched spots, but it's the same exact thing. So in other words, whenever I'm doing a combination, All right. If the R values add up to the N value, then I'm going to get the same exact answer. So look here, 2 plus 3, what is that? Well, that's 5. So that means 5 and 3, the combination for that is going to be the same as the combination of 5 and 2. And that's true for any combination. All right. So if I did the combination of 10 and 6, I would get the same thing as the combination of 10 and 4 because 6 plus 4 is 10. Very good. Okay, another thing I want to point out to you is a shortcut. So once again, if I look at this, I have 5 factorial divided by 2 factorial times 3 factorial. And what ended up happening is if I write out 5 factorial, that's 5 times 4 times 3 times 2 times 1. That 3 times 2 times 1, well, that part right there, just look at that part. That is the same as 3 factorial. That's why it cancels. All right, so a shortcut for this, a way you can just jump straight to here, is you're always going to look at the top. You're going to look at the bigger factorial on the bottom. All right, so in this case, we have 3 factorial. And what you're going to do is when you go to write out 5 factorial, once you hit that bigger number from the bottom, you don't even have to write it. You can just stop. So I could have just written 5 times 4, and then once I was going to hit 3, I could have just stopped and gone ahead and canceled out that 3 on the bottom. All right, very good. Let's look at the next part of the notes, and let's talk about the difference between combinations and permutations. So like I said, I wanted you to be able to do the formula. Now let's talk about what these are actually used for. So we have 2 examples. Combination example 1 says, how many ways can we pick a team of 3 students from a group of 15? And then permutation example says, how many ways can a 15 student competition result in a first place, second place, and third place winner? So the first thing I want you to pay close attention to is that in the combination example, the order that I pick the students in does not matter at all. It doesn't matter if they're male or female. It doesn't matter how I arrange them. I just need to have a team of 3. Whereas over here in this example, the order does matter. Somebody is very clearly going to be the first place winner, somebody is very clearly going to be the second place winner, and somebody is clearly going to be the third place winner. So in this one, the order does matter. So right there, that's the distinction between why you use the different formulas that you do, okay? So that's the first thing. The next thing I want to point out to you is we're going to draw a little diagram. So I'm going to go ahead and do that. All right, so here in my diagram, I have 15 students. And looking at this combination example, if I'm going to pick a team of 3, well, I could pick these 3, I could pick these 3, I could mix it up a little bit and jump around. I could pick this person, and this person. It doesn't matter, like I said, as long as I have a team of 3. In fact, uh, in combinations, sometimes you'll end up with the same result, but they're not 2 separate outcomes. They're actually one and the same. So I'll show you what I mean by that. Let's say I picked 3 students out of my 15 and I picked John, Bob, and Sarah. Okay, then let's say I tried it again and this time I got the same 3, but I got them in a different order. Sarah, John, and Bob. Again, it does not matter as long as I have 3. So in a combination, these 2 are actually the same exact result. Even though that uh, the order was different, these 2 are the same outcome. So we don't count this as 2 separate events, we count it as one event. This is why combinations are always going to be less than permutations. Okay, if we look at the other example, when we're talking about a competition, these 2 outcomes are actually different. If I was to pick John, then Bob, then Sarah, John first place, Bob second place, Sarah third place, that is not the same as Sarah getting first place, John getting second place, and Bob getting third place, because it's competition, so the order matters. in this case, we would treat these as two separate events. Even though it's the same three people, there are two separate events here. Okay, so now that we understand a little bit more about the difference between these two, let's actually do this. We're going to actually use our formulas and see if we can figure this out. All right, so in the combination example, I have my total group. All right, so N is always going to be my total, and I know that is 15. R is always going to be the number I'm choosing. So number selected, and in this case, I'm selecting 3, right? And for my formula, remember I have N factorial on the top divided by R factorial times N minus R factorial. And of course, 15 minus 3, I know that is 12 factorial. So, woof, right? Look, I could write 15 times 14 times 13 times 12 times 11 all the way out. That's going to get crazy. But let's instead use our shortcut, remember? If I know that this 15 factorial is eventually going to hit 12 anyway, and it's going to cancel with this 12 factorial, then all I need to do is just write until I'm about to hit 12. So 15, 14, 13, and then I'm going to stop because then I would hit 12. And I know the rest is just going to cancel with this. Okay, very good. Now I'm going to divide that by 3 factorial. So I have 3 times 2 times 1. Now these are some really big numbers, but if I put them in a calculator, I'm going to get 2,730 on top. That's 15 times 14 times 13. And I'm going to get 6 on the bottom. That's 3 times 2 times 1. And then I'm going to put this in a calculator. 2,730 divided by 6 gives me 455. So out of a group of 15 students, I can pick a team of 3, 455 different possible ways. Okay, now let's jump over to the permutation example. In this example, same deal. N is going to be the total. So there's still 15 students. R is going to be the number I'm selecting, so it's still going to be 3. But remember, the formula is slightly different here. So in this one, it's going to be N factorial divided by N minus R factorial. Clean this up just a little bit because I know 15 minus 3 is 12. All right, and once again, I can use my shortcut, right? If I know I'm going to divide out 12 factorial anyway, and I know that this 15 is eventually going to hit 12, then all I need to do is start from 15, and once I'm about to hit 12, I'm going to stop. So that's what this is going to be equal to. So 15 times 14 times 13. Okay, now I actually already did that over here. 15 times 14 times 13 in a calculator is 2,730. So even though I'm using the same numbers, 15 and 3, the permutation example is going to be way bigger because, like I said, these two outcomes, we treat them the same because they're the same people and the order doesn't matter. And so you end up with a much smaller amount of possibilities. Whereas over here, these two outcomes are not the same because the order they're picked in matters. So you end up with way more possibilities. There are 2,730 possible ways that 3 people can place in a 15 student competition. All right, now down here, what I want you guys to do, I went ahead and told you for these last 2 problems whether or not you're using the combination formula and the permutation formula. So I want you to pause the video and I want you to actually see if you can solve these 2 problems on your own. try that out, and then I will, of course, give you the solution in 5, 4, 3, 2. All right, so if for the combination example, you said that your N was 20 total toppings for the pizza, and you are choosing 3 of them, you should have done the formula and gotten 1,140 possible types of pizza. And then for the permutation example, if you said N is 15 total players and R is you're arranging 7 of them on the batting order, and I went ahead and highlighted the word order for you because that's how you know this is a permutation, because the order that you arrange those players in matters. If you do the formula on this one, you get 32,432,400 possible batting orders. Okay, if you got those two, very good job. If not, go ahead and fix those mistakes right now. All right, that's it for this lesson.